So we're at 11.1 today. We're learning the first of 4 types of transformations. All right, so as I was kind of like prepping you guys for today's lesson, that's what we were talking about, that transformations occur within the coordinate plane. And there's 4 different types of transformations we're going to learn. So the first one today that we're going to learn is something called translations. Before we get too far into translations, I need to review the coordinate plane with you. It's my understanding that you have learned ordered pairs and how to plot them on the coordinate plane. So we're going to, for points A and B, I want you to give me the ordered pair that is represented by each point. And then for C and D, you're going to plot those yourself on the graph. So let's start with A. All right, if you think you have an idea, go ahead and write that down. The ordered pair that represents point A. All right, just as a reminder, an ordered pair starts with the X value and then the Y value. All right, so what does that mean? That means the axis that goes left and right is the X axis, and the axis that goes up and down is the Y axis. So the first number that we're looking for is the X value that lines up with point A. Do you see that? So what X value lines up with point A? -2. Did you guys write that? Anybody get that first? Okay. And then what Y value lines up with point A? 2. So I've had people ask, well, Ms. Kinner, like, what if I get those just like switched around? I say 2, -2. Do you think that would still be correct? No, because it has to be in that specific order. All right, try B. Try B. Lydia, what do you think? Very good, 2, -3. So now we're going to plot point C. So this -3 that occurs first, that tells me what X value this point needs to align with. And then the 4 tells me what Y value the point needs to align with. All right, so would I go left on the X-axis or right on the X-axis to go -3? I would go left, and then would I go up 4 or down 4? I would go up 4 because 4 is positive, and I would plot point C up at -3, 4. All right, go ahead and do D. Okay, is your point D right here? Okay, right 4, up 5. All right, so it's really important that we understand how ordered pairs work in the coordinate plane because everything in chapter 11 builds on that. Every single thing you're going to learn is done within the context of ordered pairs in the coordinate plane. All right, so back to our terms, back to chapter 11. We have 2 main terms that we need to know here. The first one is a transformation. A transformation, remember, that is the title of all of chapter 11. So what are these transformations? Well, a transformation changes a figure into another figure. And that new figure is called an image. You're going to hear me say that word a lot over the next couple weeks. The image is the new figure after the transformation has occurred. The first type of transformation we're learning is a translation. That is a transformation in which a figure slides, but it does not turn. And I would add to that, it does not change size. Okay? It does not change size. Okay, so it has to be the same size as well. Okay, every point moves, and that's basically what this next sentence is saying. If every point moves the same distance and the same direction, it will not change size. Okay, it's basically just shifting left or right, up or down. That's all that's happening. If one point moves farther than another point, it's going to look like a different figure, and that's a problem. All right, so translations slide, they do not turn, and they do not change size. So that's important when we're just trying to identify between 2 figures, is it a translation? All right, so we're just kind of warming up to this idea of running through the criteria. All right, does it turn? If your answer is yes, it's not a translation. If it changes size, it's not a translation. So what do you think on this first one? Is it a translation?
Yes, it is.
Yeah, because it doesn't turn and it doesn't change size. So yes, it's a translation. Okay, you do have some of these on your homework. All right, next one. Is it a translation?
No.
Okay, you say no. Can you tell me why not?
Because it turns.
There's the word. It turns. Okay, so that's what I said. I believe your homework asks for an explanation. Your explanation would be to tell me what is disqualifying it. Okay, what is making it not a translation? Here, it's because the figure turns. Okay. What about my third one?
No, it changes the size.
Okay, so they're clearly different sizes. And guys, I'm not gonna try to pull a trick on you and make them barely different sizes. Okay, so we'll make it really dramatic. Obviously, these change size. So I would say no changes size. Okay. Yeah, I know. So that's it. All right. So your notes. Okay, so that's a good point. Your notes are really thick. Did you notice how thick the packet was? That's because we have stuff like this in here and we have tons of graphs in these notes too. So that's going to take up a lot of space. It doesn't necessarily mean they're extremely long lessons. Okay, all right, so here's where we're really going to kind of get into what makes a translation. Now, method 2 we're actually doing on the next slide, so we're not going to do method 2 right now. We're going to focus on the graph. Okay? All right, so focusing on the graph. What I do want you to see side by side is that there are 2 different methods that can get you to the exact same answer, depending on the information the problem gives you. So if the problem gives you a graph, there's no point in pulling the ordered pairs out and doing method 2 when you have the graph right in front of you. All right, so what do I mean by this? We see what shape is on the graph. What shape is that? That's a triangle. It has 3 points, okay? And we have some instructions here. It says to translate this triangle, let's see, translate the triangle 3 units right and 3 units down. Here's the question. What are the coordinates of the image? Now remember, the image is the new figure after the transformation has happened. All right, so how do I know what the new coordinates are going to be? I need to follow the instructions for the translation. If I'm going 3 units right and 3 units down, I can look at the graph. Okay, so just look up here for a minute. Don't draw this on the graph because we don't want a bunch of lines everywhere, but just look up here for a minute. You can choose any point to start with. You're going to follow what it said. 3 units right, 1, 2, 3, and 3 units down. 1, 2, 3, and you're going to plot your new point. Okay? Does everybody see how I got to my new point B? So I'm about to erase the little dashes. Any questions on how I got to my new point B? Okay? All right, so I'm going to plot my new point B. And I'm going to go ahead and label it B. Okay? And I'm going to add something to it. I'm going to add an apostrophe after the B. I'm going to talk more about that apostrophe in just a second, but let's go ahead and move the rest of our points. So for point C, remember with the translation, I have to move each point the same distance. So I'm going to follow the same code. Again, for point C, I'm going to go 3 right, 1, 2, 3, and 3 down. 1, 2, 3. And my point C goes here. And I'm going to make it C prime. Okay, and then for point A, I'm going to go 1, 2, 3, 4, -1. Okay, so for point A, I'm going 1, 2, 3, 1, 2, 3. Okay, so why in the world am I putting these apostrophes after the letters? Well, let's say, do you have a guess at it, Aiden?
Is it because, is it to tell people that it's been translated?
Yes, that's exactly right. If I didn't have the apostrophe, if someone was just looking at this, they wouldn't know which one was the original. So to put the little apostrophe after each letter, I can see that this top figure was the original and the bottom figure is the new figure. That's important for in a minute. Okay? now we're going to connect these points with a dotted line. So again, why do you think I would use a dotted line on the image versus a solid line?
For the same reason as the apostrophe, so that they know it's not the original one.
That's exactly right. Okay, and when you look at these figures, they should look like the same figure. All right, and that is a translation. Okay, all right, so you have a homework problem that's pretty much just like this. Okay, now it says, what are the coordinates of the image? Now the only thing I need to do is say what the new ordered pair for A prime is. What's my new ordered pair for A prime? Does everybody see 1, -2?
Yes.
Okay, go ahead and write your new ordered pairs for B prime and C prime. And again, the only reason we're using that apostrophe is to show that this is the image. All right, what'd you get for B prime, guys? Just tell me.
5-2.
5-2, very good. And what'd you get for C prime? 4, yes, 4 -1. Okay, any questions on how we came up with those ordered pairs? Anything? Okay, so method 1, if I'm given a graph and I'm looking at a graph and it says translate, okay, that's exactly how they would do it. All right, now let's look at method 2. This actually is the same set of ordered pairs, okay? But now we don't have a graph in front of us. So I'm showing you a side-by-side comparison between the methods here. Now I don't have a graph where I can say, okay, well, these are my original points and I need to count the units, 3 right, 3 down. Now I have ordered pairs. So how could I find the new coordinates without actually graphing this? Okay, that's like rhetorical, okay? I'm about to tell you. How could I find the coordinates without actually having to graph it? Here's how. All right, and this is so important. This is like the most important thing in the lesson right here, guys, okay? If you translate these 3 ordered pairs, we're going to go ahead and write the ordered pair point A, but I want you to spread it out. You see how I kind of left a gap after the X value and a gap after the Y value? Go ahead and write your original point A that way. Okay? Go ahead and write that down. All right, so how do I know what the new coordinates for point A would be?
Add 3.
Ugh. Okay, all right. This is what I would do. It says you're going to translate it 3 units to the right and 3 units down. So it doesn't actually say that I need to either add or subtract, but I know that which axis goes left and right. Which axis goes left and right? The x-axis. So if it's saying right, it means I'm doing something to the x value. And if I'm going right on the x-axis, do you think that would be adding or subtracting? It would be adding. So that's how I know that I'm supposed to add 3. Okay? Now, if I'm going 3 units down, which axis would go down? That's the y-axis. And if I'm going down, do you think that would be addition or subtraction? It would be subtraction. So that does make sense to us, okay? So it would be subtracting 3. Now, once you figure out the pattern is the same with all the ordered pairs. It has to be. Otherwise, you're not going to have a translation, okay? So the new point A would be just solving this. What's -2 plus 3? 1. And what's 1 minus 3? -2. Okay? All right, so now let's do B and C. We'll take a break, and I'm going to kind of walk around and check on you guys. Once we figure out the pattern for point A, it's the same thing for B and C. So as you can imagine, these questions usually end up being all or nothing, right? So like if you get the pattern on point A, you're probably going to get B and C, right? But if you make a mistake, then sometimes you would see a mistake on all 3 of them. All right, so for B, you're doing the same pattern again. You're adding 3 because it says 3 units right, and you're subtracting 3 because it says 3 units down. Your new point B and C. And if you look back to the example we just did, it's the same ordered pairs for the image. Okay? So whether you translate on a graph or you translate with ordered pairs, you will end up at the same coordinates for the image. Okay? Got it? Okay. All right, so now on this one, we're going to do this whole thing start to finish. Okay, it says draw translation on the coordinate plane. Okay, the vertices of a triangle. There you go. It's triangle. That's why you have 3 ordered pairs here. Draw the figure and its image after it is translated. 1 unit left and 6 units up. So what I want to see on your graph, as I'm walking around checking you guys, all right, plot the 3 original points. Would that be a solid line connecting them or a dotted line? Solid on the original. And then you're going to follow the translation. You can start at whatever point you want. Okay, but on the translation, you should have dotted lines connecting your points, and you should have A prime, B prime, and C prime. All right, so we're going to pause here for a few minutes and work on this example. Okay, so does your original image look like this? Okay, does your original one look like this guy? Does it look like that?
Yes.
All right. And then does your new one look like this?
Yes.
Did you do your A prime, B prime, C prime? They're in the same order and your dotted lines. So when someone looks at this, all right, and I think you might have one of these on your homework, where they actually show you what you see on the graph. And they say, how was this figure translated? How do you think you could figure that out? Okay. All right, look here, guys. Look. So all you do, we call them corresponding points. You can probably assume what that means. Corresponding means it's going to be the same point on the figure. So if you don't know what the translation is and they're asking you, you would just count. How many did you go up and over, which way? And you would say left 1, up 6. Okay? Yes.
If you had to figure that out, like when we moved,
Yes.
once you find out the letter 1, like one letter, you know the rest.
Absolutely. All the rest of it. So you only have to pick one pair of corresponding points because all of them will be the same. If you pick B, it's going to be the same thing. Okay? So, Samuel?
Whenever we do it, would we put like 1 unit left or just?
Yes. Yeah, we're actually about to do one, but yes, you would say 1 unit left, 6 units up, just like you see in the instructions. Maddie? Yes, but you'll have one. You'll have one. I'll explain that in a minute. All right, Aiden?
Well, can you do a little shortcut to when you're finding that thing? Because C, in the original understanding, C was 2 units away from A, so when I found the new coordinate of C, you already know it's 2 units away from A.
Oh, yeah. Well, you're kind of on the next level right now, but that's exactly right. Okay, if you weren't following what he said, that's okay. But you're thinking exactly right, so that's great. Okay? All right, let's look at the next example. We are not going to graph it because I'm actually going to let you save this graph for number 14 on your homework. Okay? And we don't need to graph it anyway. Okay? So we're going to save this for number 14 on your homework so you don't have to do your own. Modeling real life, how could this apply, to something that we might see on a daily basis? Well, if you're a landscaper and you're working in a park and you want to do some, kind of like renovating in a park. All right, so that's the scenario. This landscaper draws a square with vertices as the following. Okay, so there's all your vertices. To represent the location of a new fountain. So he wants to put a fountain in, but he wants to make sure it's going to fit and look good. And the city officials are like, nah, it's so much. We don't want it there. We want to move it. 4 units left, so maybe a unit stands for 10 feet. Okay, and 6 units up. So if this graph, okay, even though we're not going to use it, if it represented the park, we basically want to make sure that it's going to fit. Has anybody ever rearranged the furniture in your bedroom? Has anybody ever done that and then the new spot didn't quite fit? Like something like stuck out into the doorway or the dresser didn't quite fit right and then you just had to move everything back? Okay, that's kind of what we're talking about here with the translation. We want to make sure if we're shifting something that it's going to fit where it ends up. All right, so are you kind of connecting a little bit?
Yeah.
So now we're just going to basically do what we've been doing in all the other examples. But I want to practice using the ordered pairs. That's why we're not going to do it on the graph. I want to practice the operations using the ordered pairs. All right, so let's get our ordered pairs. Okay, and now we have to decide. Now the translation tells us, please don't say this answer out loud, okay? I want everybody to think, okay? We have to decide what is happening to our x value and what's happening to our y value in terms of addition or subtraction. The translation will tell you, okay? So I'm going to highlight the translation here. Okay, the translation tells me if I'm adding or subtracting from x and by how many. And if I'm adding or subtracting from y and by how many. Okay, so think about it. Okay, someone raise your hand and tell me, what are you doing to the x value? All right, I'm hoping for like 18 hands to go up. All right, Alexa, what do you think? Yes, I'm subtracting 4. How did she know to minus 4? Y'all can tell me. How did she know to minus 4? Because it's going left. Okay, so left means subtraction. All right, Joel, what am I doing to y?
You're adding 6.
I'm adding 6. How did he know to add? Because I'm going up. Okay, is everybody clear how I knew to subtract 4 and add 6? Now, you can see that I've kind of condensed this down from the first time I showed you. The first time I showed you, we had those big gaps inside the parentheses. Really, I expect you eventually to do all of this in your head, okay? To be able to just, oh, I'm subtracting 4, 1 minus 4, okay? I'm adding 6, negative 2 plus 6. However, I do want you to still show that pattern, at least for now, okay? It just really keeps your thinking a little more clear when you can see it on paper. But you can just simply do what I did. You can write it above each value. All right, so guess what? Now that you know the pattern, what's it going to be on every single other one? It's going to be the same pattern. It has to be because every point has to move the same distance in the same direction. Okay, so let's take a break for about a minute or two and come up with our new ordered pairs, the coordinates of the image, and that would answer this question. So, did you get negative 3? Hold on, I forgot I wrote the pattern on all of them. Did you get negative 3, 4?
Yes.
Okay, someone raise your hand. Samuel, what'd you get for B?
Negative 1, 4.
Good job, negative 1, 4. And what about C, Jack?
Negative 1, 2.
Very good. And D, Addie? Negative 3, 2. Good job, guys. All right, so there's one thing that I left off the notes that I do need to talk about, but before I do that, can I answer any questions? Okay, so what if I gave you the starting ordered pair and the image, and I said describe the translation? Please don't say the answer, okay? Here's what you don't do when you describe. You don't say add and subtract. You would say the actual direction. So from the original x value to the new x value, if you are adding, what word would you say? Right. Right? Okay. If you were subtracting from the first x value to the second x value, you would say left. Okay? So don't say add and subtract, but you know if you're adding to the x, you would be moving right however many units x is increasing by. Okay, so in this first one, I would be moving right how many units from 8 to 10? 2. I would move right 2 units. Does everybody agree that 8 plus 2 is 10? Okay, so that's why I would say right 2 units. Okay, if you say 2 units right, that's perfect. Now, from 5 to 7, okay? Because now I'm describing the y value, is it still going to be left and right?
No.
It's y, now it's up and down. So as you can assume, if my y value is increasing, and this is only ever addition and subtraction with translations, okay? If it's increasing, I would be moving up by however many, or if it was decreasing, I would be moving down. Okay, so this one would be up how many? 2 units. Okay, so that's how you would describe the translation. So I'm going to give you one. It's a little harder. All right, and I want you to describe the translation just like we just did. Okay, so Colin answered that correctly. He said 6 units to the left because I know from a 2 to a -4 on the x-axis, I'm going from a 2 all the way to -4 that I would be subtracting 6 or going 6 left. And then from a -4 on the y-axis down to -6, I would be going down 2. So that's why I say left 6 units and down 2 units. All right, and if you understand that, that's everything you need to know for 11.1.